Hey Mike, I'm going to go through the example you posed. We're going to take a motor, we're going to move it, a stepper motor, we're going to move it 3,800 steps in one direction, wait for an input, and then move it back the same number of steps. The 3,800 came from the 190 steps per inch, and you're wanting to move it 20 inches. So this the 20 times the 190. So we'll go ahead and we'll set up a new project. Call motor move, and you've got an ACE22. So the thing we need to select here is we need to select the stepper output, the step, and the direction pin. I'm just going to leave them with D1 and D2, but you can change them if you need to. And I'm going to set this up like a state machine, and you can see in our other tutorials, if you go into the software tab under tutorials, you can see some other examples where we describe state machines, but I'm going to set this up as one. So first thing I need to do is initialize the state machine, and we'll make state a UI16 in this case, and now we'll create our state machine loop, and we'll check if state is equal to 1, and the first time it will be. And what we'll do is we'll go ahead and we'll make the first movement here. So we're going to go to move 3,800 at a rate of I believe you said you just needed a minimum of 1.2 microseconds, so 100,000 a second should be fine. We'll give it a 1,000 millisecond ramp up speed, and we'll create a variable for this. And inside this variable, that'll store the current position that the motor's at. And the last thing we need to do here is we need to advance our states. So we'll put a 2 in the state. And we'll loop back around. So now after it's finished this step, it'll loop back around. It'll be state equals 2. And now what we need to be, I'm going to do Control C and copy that block. We'll check to see if it's equal to 2. And we need to be comparing the location to our desired location, which in this case is 3,800. Once it gets there, you're wanting to wait for an input bit, so we'll do that in the next state. We'll move it to state equals 3. And inside state equals 3, we will check to see if that input bit has occurred, or if it's on. So we'll just pick B1 in this case. And if it is, then I'm going to take this motion block and I'll modify it. Instead of going to 3,800, we're going to go back to location 0. So it's at 3,800. We'll bring it back to 0. And we will, I'll condense this a little bit so I can put another copy here. Go to state equals 4. And in state equals 4, we're going to check to see if location is equal to 0. If it is, we will, in this case, we'll advance it to step equals 5, but you could do something where maybe you you waited for another input bit, and then maybe you moved it forward again, something of that nature. But we're going to just move it to 5, which we're not going to create a state equals 5. This will just basically finish the program for us. Put this here to make the wires go a little better. Okay, all done with that. Okay, so just going through it here, it's going to start out, it'll make it equal state equal to 1 at first, and then it'll check what the state is. State will be 1 the first time. We'll tell it to go ahead and move to location 3800, which is your 20 inches out. We gave it a speed of 100,000 pulses a second, and we told it ramp up over the period of a second, 1,000 milliseconds. And then we tell it to go to state equals 2. State equals 2 is here, and it's just waiting for that 3,800 pulses to be sent, or steps to be sent. And once it is, we advance to state equals 3, wraps around here again. And here we're just sitting here waiting for this input bit to become true. And once it is, we move our stepper at the same speed and same ramp soft start. We move it back to location 0. And then we go to state equals 4, which just hangs out waiting for a location to be equal to 0. And what it is, we move to state equals 5, which isn't going to do anything. So that's the basic idea of what you need to do for your application, and I'll go ahead and send you the files.